In this lesson, we're going to continue the study of regular polygons. I have an 8-sided polygon drawn here just so, for the sake of reference, so you're reminded of what we're talking about. Once we have the formulas, we don't even really need the figure, but it's helpful visually to see what the elements of the figure. So just as a reminder, I put this up here. In these problems, we're going to find a missing apothem. You'll see that I have the formula for the area of a regular polygon would work for any polygon in representing the number of sides, S, the length of each side, and A, the length of this apothem. Remember, the apothem is a line that's drawn from the center point, and every regular polygon has an exact center from the center point to a point perpendicular, from the center point perpendicular to the any side actually would be the apothem. The length of from there to the side itself would be the apothem, and I could draw an apothem on any side. So we're going to find a missing apothem. That's the part that's going to be missing. We're going to find it algebraically. So let's just see what happens here. We know the area is 55. These are all the givens. We know that 1/2 is 1/2. Our S is 3. Our N is 9. And our A is yet unknown. We don't know that yet. And I use parentheses just to remind myself that I'm going to multiply. You don't have to. But if you don't, and you just write the numbers side by side, sometimes you might walk away, come back, and forget what you're doing. And 3 times 9 suddenly looks like 39. So just remind yourself that you're multiplying. That's why I did that. And I'm going to just do a quick calculation here. There's a number of ways to go about simplifying this. I'm just solving for A now. And what I did was I took 1/2 times 3 times 9, and I calculated that to be 13.5 A. That's one way to do it. Some people might start by multiplying by 2 and then divide 3, divide 9. That would work too. I'm not going to go through the details of the algebra because you've already had solving in algebra and solving lines. So then the final step is to divide both sides by 13.5. And for the measure of the apothem, you get 4.074. And I actually rounded that. It goes, if you put that in your calculator, you're going to see it continues to go on for quite a ways, probably the length of the viewer of your calculator. And I rounded it to 4 decimal places, just because in the problems I saw that seems to be the apothems were given in 4 decimal places. That must be an appropriate amount of accuracy for most measurements. So the apothem is, and it would be in inches in this case, so 4.0741. So you can see, not that difficult, just some good practice with algebra. Really, here's the reason for doing these. That's the main reason. Now I do want to, and I will concede that you probably never find, or rarely find, an apothem this way. Most likely, if you needed to know a length of a figure, that line, you would find it using trigonometry. You could construct it and measure it, although probably it'd be more likely you'd find it using trigonometry because the calculation would be more precise than your measurement in the end. And while you're sitting there saying, but this is baloney because I've never worked with a figure like this anyway, never say never. If you went into careers like architecture, design, engineering, construction, it is not unlikely that you would encounter a figure like this. If you would encounter a figure like this, if you look around at architecture buildings, if you walk into like state capitol buildings, for instance, you're going to see all kinds of different shapes and figures in those kind of buildings because people want them to be interesting. The building becomes like a piece of artwork. So they'll use figures that are not normal, not practical, just so that it looks more interesting, it's more appealing. So it is a possibility. Never say never. Someday you might. Let's look at another figure. So we got area is 37, we'll say millimeters squared. The side length is 3.2 millimeters, and the number of sides for this figure is 7. Should put an S there. So let's put it into the formula and calculate. That's all there is to do at this point. 37 equals 1/2 times length of the side is 3.2. The number of sides is 7. The apothem is unknown. So it sets up exactly the same as the one we just finished working out. So go through the calculations. I'm going to do the same thing I did last time. I multiplied these together, 1/2 times 3.2 times 7, and I ended up with 11.2. Check my work on that to make sure it's right. And then divide both sides by 11.2 just to finish the algebra. Again, these problems are a good opportunity to practice your algebra skills. And you end up with 3.3036. You can look at your calculator when you finish the calculation. You'll see that it's a lot bigger, messier number than that. I rounded it to the 4th decimal place, which would be the 10th, 100th, 1000th, 10,000th decimal place to get our final answer. And of course it would be millimeters, because that's our original units. That didn't include units in the algebra, because that can get kind of messy and confusing. Your teacher may want to show you how the units work out, because they do, which can become valuable, especially when you do scientific calculations. But for now, we know that that's a one-dimensional unit, so it ends up being, and we're measuring in millimeters, so the apothem is going to be, that almost looks like comma, the apothem will be in millimeters. So that's all there is to it.